Hello everyone, welcome to Payone Tech Video. In the previous videos, we went over different examples of IPv4 Class C subnetting. In this video, we will talk about different types of questions you might see regarding subnetting. And we will go over some examples and how can we answer those questions. So stay tuned, let's jump into my computer and have a look. So one type of question you might see, let's say I'm going to write down question 1. Let's say they might give you network address 192.168.1.0 with the default subnet mask. Now, of course, this is Class C, so it will be 255.255.255.0, and they might say we need 50 number of hosts. We don't need 254 because by default Class C, going by default subnet mask, gives us 254 available IP addresses. So this is one type of question you might see. Another, let's say I'm going to write down question number 2. They might say, okay, this is our network address 192.168.1.0, default subnet mask. Of course, this is Class C, right? 192 Class C network. Default subnet mask is 255, 255, 255, and 0. And they might say we need 10 different subnets. We know the default 255, 255, 255, 0, that's just one network. So this is 192.168.1.0 network. All the IP addresses in this network, they can communicate. They can talk together. This is just one big network with 254 available IP addresses. So they want 10 different subnetworks. For example, let's say to use one subnet for accounting department, one subnet for marketing department, one subnet for the sales department, and so on. Another type of question you might see, I'm going to write down question number 3. They might give us IP address. So I'm going to write down 192.168.1.68, for example. And they might give us a CIDR notation, let's say 29. And they might say, what is this address? If this is IP address, this IP address belongs to what network? If this is a network address, let us know if this is the broadcast address, that the broadcast address belongs to what network. They might give us one IP address with the CIDR notation, and depends what type of question they might ask after that. But we will go over all of them. And then another type of question, I'm going to write down question number 4. They might give us IP address 192.168.1. Let's say 118, and they might give us a subnet mask of 255.255.255.192, and they might say this IP address belongs to what network. So these are different types of questions that you might see. For this example, I just used Class C network, and in the future we will go over Class B and Class A IPv4 subnetting. Okay, first let's go over question number 1. Question 1. For question 1, they give us the network address of 192.168.1.0 with the default subnet mask of 255.255.255.0 because this is Class C network address, and the default subnet mask for Class C, as we can see here, 255.255.255.0. And they are saying we don't need 254 available IP addresses. We only need 50. We don't want to waste all those additional IP addresses. So what we have to do first? Well, here they are asking number of hosts 50. And earlier we talked about in order to find out the number of hosts. So number of hosts, 2 to the power of host bits minus 2. So we also talked about going from right to left at the bottom, starting with number 2. That's the number of hosts. So 2, 4, 8, 16, 32, 64. They're asking for 50. This block 64, it's perfect. So 64 minus 2 is 62. Let's erase this. 62. So 62, it's enough IP address. Basically, it meets the requirements. They are asking for 50, and we are not wasting too many IP addresses. So we can draw our cut line here. So the subnet mask was 255, class C default subnet mask, right? 255 and 255.0. But what happened here? We borrowed 2 bits from the host bits. So the original cut line was here, and we moved the cut line 2 bits to the right. Anytime when we are moving the cut line to the right, that's subnetting. When we move the cut line to the left, that's supernetting. We will go over supernetting in the future videos. So all the additional bits here, it's pretty much off. These are the host bits. Zeros, host bits, ones, network bits. And of course these are our subnet bits. So all the network bits here, and these 2 subnet bits, and here all these zeros, host bits. And that's it. We just solved the problem. So here, when we have the cut line, the last bit that is turned on, this is our network increment. In this case, 64 is our network increment on the last octet. The network address here they gave us 192.168.1.0. So if I write down 192.168.1.0, what is our new subnet mask? So we borrowed 2 bits here, right? So it's 255, 255, 255 on the last octet. On the last octet here, 2 bits we borrowed. So 128 plus 64, that is 192. So the subnet mask is 255, 255, 255, and 192. That's our new subnet mask. And the CIDR notation is 26. So up to here, the original default subnet mask for class C is 24 bits. 8 plus 8, 16, plus 8 ones here, 24. And these 2 borrowed from the host bits. So it's turned on now. It's part of the network bits basically. So 24 plus these 2, 26. So the CIDR notation is 26. And the increment, the last bit turned on, decimal value is increments 64 on the last octet. So if you want to write down 192.168.1.0, our first subnet, 192.168, 1 dot incrementing by 64, and then 192.168, 1 dot 128, 192.168, 1 dot 192, and that's it, because the next one is 192.168 2.0 or 192.168 1.256, but 256 we don't have. These are the 4 subnets, and every subnet we can have up to 62 available IP addresses, which yes, again they ask for 50, but remember it goes by block numbers, and this block is the closest one that meets the requirements, 62 available IP addresses, and not wasting too many IP addresses. So again, the number of hosts, 2 to the power of host bits minus 2. How many host bits? 1, 2, 3, 4, 5, 6. All these zeros considered host bits, ones considered network bits. So we have 6 host bits. 2 to the power of 6 minus 2, which is 64 minus 2, it is 62. Every subnet we have 62 available IP addresses. To show you, let's erase all this. In order to find the range, it's better to have the network address and the broadcast address, and then we can write the available IP addresses in between. So the broadcast address is 1 less than the next subnet. Next subnet is 192.168.1.64. 1 less IP address is 192.168.1.63. So let's write down here 192.168.1.63. That's our broadcast address. And the first available IP address, 192.168.1.1, and it goes to 192.168.1.62. So 1.1 to 1.62. And here, as we can see, every subnet gives us 62 available IP addresses. They are asking for 50. Very good. We have even a couple more IP addresses just in case, but we are meeting the minimum requirements. On this subnet, exactly the same. We will have 62 available IP addresses. And a broadcast address for this subnet would be one less than the next one, which is 1.127. 1.127. So 192.168.1.127. And same thing, the first IP address, the first usable IP address would be 192.168. This is 64, so it would be 65. And it goes to 192.168.1. This is 127, one less than broadcast address, 126. That's the range. So 1.65, 1.66, 1.67, and so on. And when it gets to 1.126, that's the last available IP address. 1.127, that's the broadcast address. And 1.128, that's the next subnet address. So the network address of 192.168.1.0 with the subnet mask of 255.255.255.192 will give us 4 subnets. Each subnet we can have up to 62 available IP addresses. Quick recap, this was for question number 1. Question number 1, they gave us a network address, default subnet mask, asking for 50 hosts. What we did, first finding out how many bits do we have to borrow from the host bits in order to subnet and having enough number of IP addresses, available IP addresses. So in this case, 2. Why from here again? Class C, default subnet mask, we have 24 ones. So previous videos we talked about the default subnet mask for class A, B, and C. So this is the default subnet mask for class C up to here. That's the default cut line. So these are zeros, the host bits. We borrowed 2. And now we have 6 host bits. So 2 to the power of 6 minus 2 gives us 62. And 62, it covers the 50 hosts. We will have 62 available IP addresses, and this will give us 4 subnets. Let's go over the next question. So I'm going to erase all this. So question number 2. For question number 2, they give us a network address 192.168.1.0 and default subnet mask, but they are saying 10 subnets. Because by default, 192.168.1.0 and the default subnet mask gives us one big network. But we need 10 subnets. So what we need to do, first we have to go through the default subnet mask. This is a default subnet mask, our cut line, right? And then finding out the 10 subnets. For subnetting, we have to move the cut line from left to right. So how many bits? Let's find out. We talked about at the bottom, if we go from left to right for the number of subnets, left to right. So starting with number 2, 4, 8, 16. That's it. So they're asking for 10 subnets. We are going by blocks. So 2, 4, 8, 16. These are the number of subnets. These 4 bits, it covers 16 subnets. So we had to borrow these 4 bits. And these are all off. Now this is our new cut line. So we can erase this one. So how many ones do we have now? Up to here, 24, plus this 4, 28. So the network address of 192.168.1.0 with the new subnet mask, if we convert all this binary to decimal, is 255, 255, 255, 240. Where this 240 is coming from, on the last octet we see 1, 2, 3, 4 bits turned on, and these 4 bits turned off. So if we add 128, 64, 32, 16, basically we just need to add the ones that are already being turned on. So 128 plus 64, that's 192, 192 plus 32, that's 224, 224 plus 16, that's 240. So this is our new subnet mask, and a shorthanded version, and by the way this is 5, it looks like 1, and the shorthanded version is / counting all the number of ones. So up to here 24, 25, 26, 27, 28. So this will give us 16 different subnets. They are asking for 10, yes, but when we go by block size, if we stop here, it will give us up to 8 subnets. They are asking for 10. So we have to go one more. Here now it gives us 16. Very good, meets the requirements, and we have a couple more subnets in the future that we can use as well. Now let's see these subnets. Okay, so the last bit that is turned on, what is the decimal value? So the last bit that is turned on, these are the decimal value at the top. 16 is the decimal value for the last bit that is turned on. So this 16 is our network increment on the last octet. So let's write down our network address 192.168.1.0. This is a 0 network. The next subnet would be 192.168.1.16. The next subnet would be 192.168.1.32. We are keep incrementing by 16. Why 16? Because after finding the cut line, the last bit that is turned on, the decimal value is 16. That's our network increment or block ID. Because we are on the last octet, we are incrementing on the last octet by 16. And why did we draw a cut line here? Because they were asking for 10 subnets, right? So we know the default subnet mask for class C, 192 is a class C. The default subnet mask is up to here. 24 bits. Ones. These are ones, 8 plus 8, 16 plus 8, 24. The cut line was here, right? So we had to see how many more bits we can borrow from the host to have minimum of 10. So the closest one, if we borrow 4 bits from the host, which gives us 16 subnets. And again, we talked about the number of subnets. It's 2 to the power of subnet bits. So in this case, how many? 1, 2, 3, 4. 2 to the power of 4. That's 16. Or we can just write down going from left to right for the number of subnets. 2, 4, 8, 16. Earlier we talked about the number of hosts going from right to left. Right to left. For the number of hosts. Starting with 2. 2, 4, 8, 16 minus 2. We had to do the minus 2. 14. So we know we will have 16 subnets. Every subnet we can have up to 14 available IP addresses. And now we are going through the subnets. So this is the first subnet, the second subnet, the third subnet. The next one would be 192.168.1. We have to keep incrementing by 16, right? So 32 plus 16, 48. 192.168.1. 64, 192.168.1.64 plus 16, 80, 192.168.1.80 plus 16, 96. How many we have? 1, 2, 3, 4, 5, 6, 7. They said 10. So we have to continue incrementing by 16. So the next subnet would be 192.168.1.96 plus 16, 112. Next one, I'm going to write down here. So the next subnet would be 192.168.1.128 because 112 plus 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's write down 192.168.1.128 plus 16, 144. That's it. These are our 10 subnets, including the 0 network. So if we need more subnets, we can continue incrementing by 16. But of course, we know this will give us up to 16 subnets. When we get to 256, that's where the invalid IP address. So to quick recap for this question number 2, they gave us the network address and the default subnet mask, and they said we need 10 subnets. So what we did, writing down the network address and then going through the default subnet mask up to, because this is class C, we know the default subnet mask is 255.255.255.0. So that's 24 bits of 1. And these are the 24 bits on. And this is the cut line here. But here asking for 10 subnets. So from the host bit, we had to borrow 4 bits. 1, 2, 3, 4. So when we borrow 4 bits, it gives us 16 subnets. If we borrow 3 bits, it will give us 8 subnets. 8, it's not enough. So they are asking for 10 subnets. That's why we had to continue, and the next block is 16, so it will give us 16 subnets. And the last bit turned on, the decimal value also is 16. Therefore, the increment on the last octet, we are working on the last octet, the cut line is on the last octet, right? So incrementing by 16. If we start writing our network address, the 0 network, 192.168.1.0, and keep continuing incrementing by 16, the next one would be 192.168.1.16, the next subnet would be 192.168.1.32, the next subnet would be 192.168.1.48, and so on. And each subnet, we can have 14 available IP addresses. For example, quickly, if I show you on, let's say, this subnet. And so the next, in order to find out the range, the easiest way to have basically the network address and having the broadcast address. How can we find the broadcast address? Finding the next subnet. How can we find the next subnet? By incrementing, right? Okay, so 64, we're incrementing by 16. This is 80. This is just one example I'm showing on this subnet, and to see the number of available IP addresses and the broadcast. So the broadcast for this subnet would be one less than the next subnet. So if the next subnet is 1.80, the broadcast should be 1.79. So 192.168.1.79. Now 64 is the network address, 79 is the broadcast address. So any IP addresses in between, these are the available IP addresses. What would the first available IP address? 192.168.1.65. 2, 192.168.1.78. So if we count 65, 66, 67, let's count. So if we count 65, 66, 77, and 78, these are 14 available IP addresses, which here we did find out 14 available IP addresses by using this method we talked about earlier, going from right to left, starting with number 2, 2, 4, 8, 16 minus 2, 14. Why minus 2? Because of the broadcast and the network address we cannot use. So when we do the minus 2, we have the available IP addresses that we can use and assign to the computers on the network. So here should be 14 available IP addresses. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So these are the 14 available IP addresses. Of course, goes from 1.65 to 1.78 on this subnet. Exactly the same on the other subnet, should be 14 available IP addresses. And here we talked about left to right number of subnets, starting at the bottom, going from 2, 2, 4, 8, 16. These are the number of subnets going from left to right. Going from right to left, the number of hosts. And for the number of hosts, we have to do the minus 2. And here the numbers to the top, these are the decimal values for these bits, which always is 1, 2, 4, 8, 16, 32, 64, 128, 1, 2, 4, 8, 16, 32, 64, 128. For the decimal values for these bit positions. So this was for question number 2. Let's move on to question number 3. I'm going to go ahead and erase. Okay, let's write down question number 3. Alright, so for question number 3, they give us IP address and with the CIDR notation 29. So they said this IP address belongs to basically what network. Or another type of question, they might say, what is this address? Is this a network address? Is this a broadcast address? Is this IP address? Based on this CIDR notation. So how can we solve this? Alright, so as we can see, this is still class C network, 192, right? But here, 29, that's a CIDR notation, how many bits turned on for the network. So the default subnet mask for class C should be 24 bits turned on, which gives us 255.255.255.0 for the subnet mask, right? But this is not 24, it's 29. So what they did, they subnetted. So what we need to do, we need to count 29 ones, going from left to right, right? 1, 2, 3, 4, 5, 6, 7, 8, up to here, 16, up to here 24. Let's continue adding. So up to here 24, 25, 26, 27, 28, 29. And these are turned off. This is our cut line. So basically this /29 means we have 29 bits of turned on, that's a network bits, and we have 3 bits for the host. And 29 plus 3, that's 32. That's how many bits we have in IP version 4. Total of 32 bits. So what's the next step? Well, you guys remember we talked about network increment? Well, here we can see the last bit that is turned on here. The decimal value is our network increment. So on the last octet. Now we need to write down the network address. So what would be the network address? Well, we have to start from the 0 network in order to be able to apply the network increment for the subnet, right? So this is the address they gave us. And if we pay attention to the first octet here, 192, so we already know this is class C. This is class C network. So what is the default subnet mask for class C? 255.255.255.0. Basically the ones that is 255.255, we just write down. So here 192, this is 168, and here 1. And here is 0. So for the host portion, 0, right? We just put 0. And this is the starting point. That's our 0 network, 192.168.1.0. Always I say that we have to start from somewhere, right? So this is our 0 network, so we can apply the network increment. Always we start with the 0 network. How can we find the 0 network? By using the default subnet mask. So when we have the default subnet mask, this is class C, this is default subnet mask. For the host portion, we just put the 0. The rest of them, we just put the actual value. So in this case, 192.168.1. 192.168.1. The host, we put 0. How do we know it's a host? Because 0 is the host. 255, it's the network. Okay, now let's go ahead and apply the increment. Incrementing by 8 on the last octet. So the next subnetwork would be 192.168.1.8. Well, with the next subnet, 192.168.1.16. Well, with the next one, 192.168.1.24. The next one would be 1.32. Next one would be 1.40. Next, 1.48. Basically, we have to keep incrementing by 8 to get to this value, basically, or see what is this value basically falls into what range. We know 68, it's not between 8 and 16. It's not between 16 and 24. You see? So it's not between 32 and 40. So let's continue incrementing. 48 plus 8, 1.56. 56 plus 8, 1.64. 64 plus 8, 1.72. Do we have to continue? Well, we don't, because here 68 falls into this range, right? Therefore, we know 68 it's in this network. So let's write down 192.168.1.64. And then let's write down the broadcast address for this subnetwork. Always I say this, the easiest way to find the broadcast address is to find the next subnet first. And then broadcast address is one less than next subnet. How can we find the next subnet? By applying the increment. So if the next subnet is 192.168.1.72, one IP address less than 1.72 is the broadcast address for this subnet. So 192.168.1.71. Now let's write the available IP addresses. So the first available IP address in this subnet is 192.168.1.65, and it goes to 192.168.1.70. So this 68 is one of the IP addresses in this range. Actually it is, well, if the first one is 65, the second one 66, the third available IP address would be 67, the fourth available IP address is 68. So we know 192.168.1.68 is the fourth available IP address in this range. So this CIDR notation of 29, it will give us a new subnet mask, right? So the default subnet mask for class C we talked about earlier is 255.255.255.0, but what is the new subnet mask? So here we can see 8 plus 8, that's 16, plus 8, that's 24. That's where the 255.255.255, right? All the 8 bits in this octet, we need to add all these decimal values. That's the 255 here. And here, 8 bits turned on. All this we add. 255, same thing. So here we can see. But this 0, well, here we can see on the last octet, we have 1, 2, 3, 4, 5 bits borrowed from the host. So 5 bits, network bits, 3 bits for the host bits. Therefore, our new subnet mask is 248. Where this 248 is coming from, basically we are converting this binary number to a decimal number. 128 is turned on, 64 turned on, 32 turned on, 16 turned on, and 8 turned on. The rest of them turned off. 0, it's off. 1, it's on. So the one that is on, we just need to add. So if we add all these numbers, we get 248. And also we do have this chart. If you remember, earlier we talked about this. Anytime when we borrow 1 bit, that's 128. 2 bits, that's 192. 3 bits, that's 224. 4 bits, that's 240. 5 bits, 248. And here we can see 1, 2, 3, 4, 5 bits borrowed, right? So it's 248. And if 6 bits borrowed, it is 252. If 7 bits borrowed, 254. And 8 bits borrowed, 255. This is also a table. It's a good idea to memorize this and remember this. So anytime 1 bit borrowed, or let's say 2 bits borrowed, what would be the actual decimal value? Okay, quick recap. For question number 3, they give us one address with the CIDR notation, and they said this address, what is it, or belongs to what network? Is this a network address? Is this a broadcast address? Is this IP address? If it's the IP address, belongs to what network? So what was the first step? We had to count. Basically, we had to apply this CIDR notation. 29, we know this IP address is a class C, 192. Looking at the first octet, 192 falls into class C network, right? So we know this is a class C network, and the default subnet mask should be 24. This is 29. So we know this is classless. So what they did, they subnetted, right? So we need to count 29 going from left to right. So here, 1, 2, 3, 4, 5, 6, 7, 8, plus 8, 16, plus 8, 24, 25, 26, 27, 28, 29. And then draw a cut line. So this is our new cut line. Therefore, gives us a new subnet mask. So this 8 bits turned on, this is 255. This 8 bits turned on, when we add all these decimal values, that's 255, 255. And here on the last octet, we have only 5 bits turned on. So it gives us 248. And then, after getting our new subnet mask, we need to find our network increment. The last bit that is turned on, in this case, this is the last bit turned on. This is a decimal value. That's our network increment. We need to increment on the last octet, starting from the 0 network. So to find the 0 network, we just need to apply the default subnet mask. This is class C, 192.168.1.68. Looking at the first octet, we know this is class C, and the default class C subnet mask is 255.255.255.0. So for the host portion, we just put 0, 192.168.1.0. That's how we can find the 0 network. And then incrementing by 8 on the last octet. Since this is the cut line on the last octet, why it's here? Because of the number 29, right? 29 bits network bits turned on. If we count left to right, 29 ones, we end up here. So draw a cut line, and 3 bits 0, that's the host bits, all these ones, network bits, the last bit turned on, the decimal value is 8, that's our network increment on the last octet. Okay, so then incrementing by 8. We need to continue incrementing by 8 to see our host information, 68. In this case, 68 falls into the 64. So we know this IP address belongs to this 192.168.1.64 subnet. And then we can find the broadcast address. The broadcast is always one less than the next subnet. So after continue incrementing by 8 here, so finding the next subnet, 72. So 1.71 is the broadcast, and then be able to write the available IP addresses in between. So the first available IP address is 192.168.1.65, and it goes to 192.168.1.70, which looking at this IP address 192.168.1.68, it falls into this range. Therefore, this is the network address, and this is the broadcast address. This is the first available IP. This is the last available IP. This is our new subnet mask, and of course the CIDR that they gave us earlier. Okay, now let's move on to question number 4. So I'm going to go ahead erase. Okay, let's write down question number 4. Basically, it's kind of similar to question number 3, but instead of the CIDR notation, they gave us the actual subnet mask. So they gave us the IP address here, and they gave us the subnet mask. They said basically this IP address, what is it? Is this IP address, broadcast, network, and if this is the IP address, belongs to what network? So what we need to do, so the first step, simply looking at the IP address 192.168.1.118, this address is a class C because the first octet here, 192, it's a class C network, right? Earlier in previous videos, we talked about all the classes, class A, B, and C. Please make sure to watch those videos. And then here we can see the default subnet mask for class C should be 255.255.255.0, but this is not 0, so that's 192. What they did, they subnetted. That's an example of classless subnet mask, not classful subnet mask. Okay, so what we need to do, we need to convert 192 into the binary, which 192, it's basically 2-bit borrowed. In other words, it's basically 128 plus 64, that's 192. So we know these two turned on, and this is the cut line, and the rest of them it's off. So we have up to here 24 bits plus these two, 25, 26. So in other words, we can just simply write down /26. And then we have 1, 2, 3, 4, 5, 6 host bits. Okay, the next step is by looking at the last bit that is turned on. In this case, this is the last bit that is turned on. So the decimal value is 64. That's our network increment. We need to apply the same. We need to write down the 0 network for this one. You guessed it right, very good. This is 192. That's class C network. Default subnet mask 255.255.255.0, right? So for the host portion, we just put 0. So let's write down the 0 network, 192.168.1.0. And we are incrementing by 64. That's our network increment on the last octet. 192.168.1.64. And we can continue incrementing by 64, 192.168.1.128. So 128 plus 64, 192.168.1.192. And if we continue incrementing by 64, we get 256. So 192 plus 64, 256. We don't have 256. That's not a valid number. We talked about in IPv4, every octet, we have the range from 0 to 255 because every octet we have 8 bits, and all the 8 bits, if all of them turned off, 8 bits 0, that's 0. 8 bits all turned on, that's 255. So we don't have 256. All right, so we know this subnet mask will give us 4 subnets. And looking at this IP address, 118, so 192.168.1.118. Let's see it falls into which subnet. 118 should be in the 64 subnet because 64 goes to 128, right? So 118 should be in this subnet. And if we write the actual ranges, so the broadcast address always one less than next one. The next one is 128, so it should be 1.127. of course 192.168.1.127, and here the first available IP address is 192.168.1.65. So I'm going to just write down 1.65, and it goes to 192.168.1.126. So 1.126, one less than the broadcast. And of course, the actual IP address 192.168.1.65 goes to 192.168.1.126. And this IP address of 192.168.1.118 with the subnet mask of 255.255.255.192 falls into this range. This 192.168.1.64 is the network address for this IP address. So this is another type of questions that you might see when we talk about all these subnettings. And if you want to continue, of course, this we just saw these 4 subnets, again number of subnets going from left to right, and then starting at the bottom, counting from 2, 4, so 4 subnets, the number of hosts going from right to left, and then starting at the bottom, 2, 4, 8, 16, 32, 64, minus 2, 62. So this CIDR notation of 26, or this subnet mask, will give us 4 subnets. Every subnet we can have 62 available IP addresses. I hope this video was helpful. Thank you so much for watching. If you have any question, please leave it in the comment section. And if you haven't subscribed to our channel and you want to see more tech videos like this, please consider subscribing to our channel. So thanks again and have a good day.